Alright guys, so today you guys are going to be learning inverse variation. It's going to be very quick. For examples, I'm going to go through some of the self-assessment problems as well. You guys slow this down as you need. Again, you can change this video to like 0.5 speed, 0.75 speed. I'm going to talk through it really quickly. So if you want to hang with me at full speed, that's fine. You just go at your own pace, all right? So today we're going to be talking about direct and inverse variation. First thing, we've got two different equations. So if we've got direct variation, all this says is that we have an equation that says y equals a times the power of x. So as one thing grows, the other thing grows by a constant ratio. It has to be exactly this. It cannot be adding or subtracting anything. All right. If we have indirect, all that says is that we've got y equals a constant divided by x. So again, a is a constant ratio. This time you're going to be dividing x on the bottom though. So in this case, as y increases, x decreases, or as x decreases, y increases. So they vary inversely. All right, so we've got a few equations here for this first example. Example number one, letter A, we've got x times y equals 5. All we're going to do is we're going to rewrite this. We're going to solve for y. All right, so we've got x times y equals 5. Hopefully you can see this okay. To solve for y, obviously we divide by x. And we get y equals 5 divided by x. If you compare that to the two equations that we have up there, this is obviously indirect variation. All right, letter B, we have y equals x minus 4. I mentioned right away that if we've got something like this, it has to be exactly like y equals something times x, or y just equals x. In this case, it's y equals x minus 4, all right? That means we're subtracting something. It cannot be indirect or direct. So this would be neither. And I guess another term for indirect variation would just be inverse variation, all right? That's the one that they say up there. So I should have actually wrote inverse variation here. If you write either one, it's going to be fine by me. All right, this next one, we've got y divided by 2 equals x. To solve for this one, again, we're just going to have to multiply by 2 here. So multiply this side by 2, multiply this side by 2. We get y equals 2x. You can pretty clearly see it's a number times x. This is going to be direct variation. All right, that's example one. Just a couple of examples here. We've got y equals 6x, so things are kind of flipped around here. This is also going to be direct variation. Y equals a number times x. This one, solve for x, or solve for y, we divide by x. We get y equals negative 0.25 over x. This is obviously going to be indirect or inverse variation. And then this last one, we've got y plus x equals 10. Immediately we've got addition there. It's going to be neither. All right, I'm not even going to write that one up there. That's going to be neither. So the next thing, the general equation y equals a times x for direct variation can be rewritten as y divided by x equals a. Similar for indirect, this can be rewritten as x times y equals a. All right, so in order to find, so like when we're given a data point, in order to find a, that's what we're going to do. We're going to take x times y, it's going to give us a, or y divided by x, it's going to give us a. And we're going to choose which one we're going to use based upon whether they tell us it's direct or it's inverse variation. All right, so for instance, if they tell us that it's direct variation, we're going to take y divided by x, we're going to get a, then we'll be able to write our equation y equals a times x and be able to find y for a certain value. All right, so they say that variables x and y vary inversely. All right, I'm just writing this down so that you can see it. That's going to be an important thing. They're going to tell us exactly which one we're going to use. And they tell us that y equals 4 and x equals 3. All right. So it's inverse variation. We're going to use x times y equals a. So in this case, we're going to take 3 times 4. That equals 12. All right. So a equals 12. Maybe I'll just write that there too. All right. A equals 12. So if we're going to write our equation now for indirect variation, y equals 12 over x. And then they just say, find y when x equals -2. All right, they tell us what x is equal to. We're simply going to plug that in. Y equals 12 divided by -2. So y equals -6. And that's it for example 3. I don't know, I might have skipped example 2 or, oh, okay. I had it kind of flip-flopped here. So I need to fix that. But example 2, we're just gonna go back to this one real quick. It's not gonna take too long either. All right, all we're gonna do is we're just gonna look, again, we're just gonna take y divided by x. If we get a value, that means it's gonna be direct variation as long as it's consistent and as long as it stays the same. Same thing for indirect, we're gonna take x times y. If it gives us the same value through each set of data points, then it's gonna be indirect. So first one, we're just gonna test to see if it's direct. So we've got 2 -12, 4 -6, 6 -4, 8 -3. We're just gonna go ahead and first we're gonna test if it's direct. So we're gonna take y divided by x. All right, so -12 divided by 2 equals -6. All right, here we've got -6 divided by 4. That's -3/2. That means these are not the same values here. It's not direct. All right, so now we're just gonna test if it's inverse variation. So now we're just gonna multiply the two numbers, x times y. So in this case, 2 times -12 equals -24. 4 times -6 equals -24. Don't stop there, there might be something down the line. Right now it's looking like it will be indirect. Here we've got 6 times -4 equals -24. And 8 times -3 equals -24. That means that it is indirect variation. Again, you're gonna have to go through and you're gonna have to test both. All right, you might recognize it right away. Like you can just do a quick visual check, like 1 times 2, 2, 2 times 4, 8, 3 times 8, 24, 4 times 16, 64. You can do that real quick. But for the most part, you're gonna have to go through and test them both. All right, now the second one, we're gonna again test direct first, see if it's direct. If it's not, then we're gonna test indirect. If it's not indirect, then it's neither. All right, so again, direct is gonna be 2 divided by 1, which is 2. 4 divided by 2, which is 2. 8 divided by 3, which is 8/3. All right, so at first, again, this is why I say don't stop right away. We have 2, 2, and then we've got 8/3. All right, so it's actually not going to be direct, even though it looked like it was for the first 2 data points. All right, this one is going to be neither. Again, we kind of tested the indirect pretty quickly when we looked at it, right? 1 times 2, 2, 2 times 4, 8, so it's not direct either. And actually, let me just make sure this is correct. Yep. All right, so yeah, we're good. All right, so in this case, we've checked everything, and there we've got our answers. All right, again, if we wanted to check this one, all right, to check if it is direct, again, we take y divided by x, 20 divided by -4, which is -5. 15 divided by -3, which is -5. 10 divided by -2, which is -5. 5 divided by -1, which is -5. All right, we can see right away that's going to be direct. All right, this one here, again, after a quick visual check, 60 divided by 1, 60. 30 divided by 2, 15. All right, I can say right away, this is not going to be direct. Again, if your mental math is good enough, you do not have to necessarily write this down, but I want to show you when we're going through this example. All right, the next thing to check, indirect. We're just going to multiply by each other. 60 times 1, 60. 30 times 2, 60. 3 times 20, 60. 4 times 15, 60. All right, so this one's clearly indirect variation. And again, just as a quick side note, direct variation, so as one thing increases, the other thing is going to decrease there. So yeah, direct variation, one thing causes the other to do something, all right? So there we would have direct, and here we have indirect variation. All right, so we're multiplying by the same number each time. or we are dividing by x each time. Last example, the time t in hours that it takes a group of volunteers to build a playground varies inversely with the number n of volunteers. It takes a group of 10 volunteers 8 hours to build the playground. All right, so a few key words here. They say that the playground varies inversely. That tells us that we're going to use this here, y equals a divided by x. All right, it takes a group of 10 volunteers 8 hours to build the playground. That's a data point. All right, they say that we've got 10 volunteers, 8 hours. That's a data point. All right. So first we're going to make a table showing the times that it takes the playground when the number of volunteers is 15, 20, 25, 35, or 25, and 30. All right, so we're going to do that first. All right, so in this case, our number of volunteers is n, and the amount of time is t. I'm just going to set up the table here quick. Number of volunteers, we've got 10 volunteers, took 8 hours, 15 volunteers, 20 volunteers, 25 volunteers, and finally 30 volunteers. You might be wondering, like, where do we go from here? All right, all we have to do is we just have to find our indirect equation. Now, again, finding our indirect equation, very, very simple. All we need to do is we just need to go ahead, multiply x times y, and it's going to give us a. All right, so in this case, a is going to be equal to 10 times 8, which is 80. So our equation is going to be, and in this case we've got t, that's going to represent our y, and then n is going to represent our x. So we're going to have t equals 80 divided by n. All right, so now all we need to do is we just need to go ahead and plug these in. So we've got the number of volunteers that they give us, so several different values. First thing, 80 divided by 15, and let me grab a calculator quick. Don't know this off the top of my head. I think it's going to be something 0.67, unfortunately, but no, it's not. It's 1/3 actually. So in this case, when you plug in 80 divided by 15, you get 5.3 repeating. All right, so about 5.3 hours when you get 15 volunteers. And when you're looking at this, it's going to make sense, right? As the number of volunteers increases, the amount of time it takes to build this playground is going to decrease. 80 divided by 20 next, that's going to be 4. 80 divided by 25, that's 3.2. Exactly, and 80 divided by 30, 8/3, 2.6 repeating. All right, and then we have it. There's our table that shows the times that it takes to build a playground when the number of volunteers is 15, 20, 25, and 30. The next question asks, what happens to the time it takes to build a playground as the number of volunteers increases? And again, I kind of just mentioned this. The amount of time to build the playground decreases as the number of volunteers increases. Right, so they're very inversely. It's one thing decreases, the other thing increases. All right, so I believe that is all you need to know. All right, so 7.1, get to work on that. That'll be due on Wednesday.